Hello, this is Jianpeng. In this short video, I'm going to explain to you how to perform the electrostatics lab. This lab has two parts. The first part is about two ways you can charge an object by induction and by contact. So first, go to the simulation. Click on Run Now. This particular simulation is pretty straightforward. Just bring the balloon here, rub with the sweater, and then let it release, and so on. I don't think I need a lot of explanation for this part, so that's all I'm going to say for this part. The second part of this lab is about electric field, and this particular part is a little bit more difficult. So again, first go to the simulation and click on Run Now. Okay, we have the field right here. Give me some time. Again, follow the instructions. Click on Show E field, basically the electrical field, and show the grid so we can see everything, and show numbers. That basically tells you the size here, the voltage here, and also we have all the positive charge, negative charge, and the sensors, E field, electrical field sensors here. The second step, what you are going to do is place a positive charge in the middle of the grid. So grab a positive charge, put it in the middle. Immediately you see all these field lines shown on this grid. Remember here the scale here. So this is 1 meter. That tells you basically from here to here that will be 0.5 meters. If you go look at the lab manual here, immediately tells you how to take a picture of this. Basically, if you have a full-size keyboard, you press Shift Print Screen, and if you have a laptop, you press F function key and F11, depending on your computer you're using. So that part should be pretty straightforward. Just follow the instructions in the manual. The second part is to actually find the E field both by calculation and by putting a E field sensor on the graph. I'm going to show you the experimental method first. That is by using the E field sensor here. So first we want to know is 0.5 meters away from the charge, what the field should look like. So if you grab a E field sensor, put it 0.5 meter away. Remember here, each grid line is 0.5, so that's 0.5. And immediately tells me at this point, the field is 33.6 volts per meter. And that's the direction, 178.4 degree. The theoretical value to do it is by applying this equation. Okay, here I'm going to show you the detailed calculation just for 0.5 meters. So again, here is the equation. The E field by definition is the force experienced by a test charge divided by the charge of the test field, and that again equals K, which is a constant, times the charge of the source divided by the distance between them, but remember distance squared. K constant is a constant. It equals 9.0 times 10 to the 9th times, in our case the Q charge is 1 nanocoulomb, so it's 1 times 10 to the negative 9th. Distance between them is 0.5 meter, so remember distance squared. So once you do the calculation, it's 36 volts per meter. So here you should say the theoretical value according to the calculation should be 36 volts per meter. And by the experimental method, which is coming from your simulation, is 33.6 volt per meter. Okay, and the remaining part is pretty similar, and just you are going to do two charges, a negative charge, and compare all those. I guess that's all for the instruction. Thank you.